Okay, good morning. Hope everybody had a good weekend and staying safe. So we're going to continue with another exercise in chapter 2 in your textbook. And so it looks like most of you already turned in the assignments that were due today. But if you haven't done so, just make sure you do post those sometime before the end of today in the discussion forum. Yeah, so I think there's 15 students and one more student that's finishing up the class. So it looks like almost all the students have posted their assignments, but if you haven't posted example 2.2 and 2.4, that's where to post it. And yeah, so it looks like everyone got the idea of how to do that, so we're good on the assignments. But example 2.2 and 2.4 due today. And so today we're going to do example 2.5, the next one, on the discussion forum and the syllabus. Okay, so this one here, example 2.5 in chapter 2, you can open up the files for that if you go to the example 2.5. Open up the Word document that has the steps and the formulas and everything. Okay, all right, and you can open up golf club demand, which is the Excel file here. Okay, and so we'll get to the practice problems later if we have time. This example I know is a bit longer than the ones we've done so far, so we'll jump right into it in a minute. Let me read the little description for this exercise here. Okay, so this is estimating sensitivity of demand to price at the Lynx company. The Lynx company sells its golf clubs to outlet stores throughout the U.S. The company knows that demand for clubs varies with price. In fact, the price varied over the past 12 months, and the demand at each price has been observed, so we can see what they charge for the clubs, and then how many people bought those clubs. All right, so this is in our data file, the golf club demand Excel file that we're about to jump to. So you'll see corresponding prices and demands in the column there on the Excel file. Okay, and the company wants to estimate the relationship between demand and price, and then use this relationship to answer some research questions. So we're essentially trying to estimate the demand curve, right? See how demand responds when price changes. That's a demand curve. Okay, so we're gonna first estimate the relationship, and then use that relationship or the best representation of that to do a little profit maximizing model. All right, so there's two portions to this. So once we get the appropriate relationship, then we're going to see when the unit cost, like the cost to produce the clubs changes, how does that affect our decision on what to charge for the price of the clubs. Okay, and then if the cost to produce, like the raw material cost or the cost of production, if that changes, does that affect our what price we should charge for the clubs? All right, so we'll use these research questions to start this example. So first, we're gonna see if we can estimate the relationship between price and demand. When price changes, what happens to demand? And then we'll use that to do some changes and see what price we should charge for the clubs. Okay. All right, so here's example 2.5. There's an optional video. We're going to do a little bit of statistics today, and so I'll explain the concepts we need to know, but there is a little video on regression, which we're doing a little bit of today, and you might have done this concept before in any stats class or econometrics, and we'll do a bit today, a little bit later in, I think, chapter 14, but I'll kind of explain as I go along, but we're going to do a little bit of statistics in today's example, and I'll explain the concepts that relate to regression that go into this example. But I'd recommend looking at or watching this optional video when you get a chance. Okay, so here's what we're going to do. So you can see that this is, we have golf club demand for this hypothetical golf club wholesale company. They have 12 months of data, and these are the prices and demands for each of those months. And demand, you can see, is in the hundreds. I don't know why they did that, but so this is 4,500. This is 10,000, so on. So these demand numbers are in hundreds. So we got to use that multiplier. And so like in month 6, the price of the clubs is 450 and demand was 5,200. So you get what happened to demand when the price changed. Okay, so first we're going to look at that data and see what the relationship looks like between price and demand. All right, we'll try some different types of curves or relationships. We'll try a linear fit, we'll try a power fit, and we'll try an exponential fit, and I'll explain what those are, but we're trying to find the best fitting relationship between price and demand, right? Okay, and then we'll get the predictions for those and look at some error terms and see which one is the best. And then we'll use the best one over in this other tab in the profit model to do the profit model with the best fitting curve, and we'll do some analyses there. So this is a two-part exercise. I think we'll have time to finish it today, but if we don't, make sure that it's a little bit longer, and so make sure that you save every step because there's a chance we won't finish it, and if we don't finish it, I want you to save it, and we'll pick up where we left off on Wednesday. So we'll try to get through it because it's easier that way, but I want you guys to ask questions and make sure you understand everything, and so make sure you're saving it just in case we need to pick up on Monday and finish up the exercise because it's a bit longer than the previous ones we've done. Okay, so here we go. Okay, first thing we're going to do is step 1 is we're going to create a scatter plot of demand versus price. All right, and we're essentially going to use this scatter plot to estimate 3 different types of fits: the linear fit, the power fit, and the exponential. And so we'll get the scatter plot, and then we'll make a couple copies of it. Okay, so let's first just make the scatter plot. Go back to the Excel file. All right, so this one's a little bit different. We don't have to do any coloring or range names for now, but you want to select all the price and all the demand data and make a scatter plot. So select, like I did, B3 to C15, select that whole area. And then we're going to want to make a scatter plot, so you can hit the Insert tab. Okay, if you have the option, you can click on Recommended Charts. And you should see the very first option, it knows what we want, is Scatter. And so you can choose that Scatter option and hit OK. If you don't have the recommended charts, you should have the scatter option anyway. So if under Insert, see how there's Insert Scatter here? All right, so you can get to it that way, but just make sure you do the scatter plot, and you insert a scatter plot here of demand versus price, and it should look something like this. All right, so saving my file. Everybody got the scatter plot? Scatter plot. We good so far?
Yeah.
Okay. So what we want to do is, because we are going to use the scatter plot for 3 different analyses, the best thing to do, rather than just make it again, actually let's format it a little bit first, and then we'll make some copies of it. So first, let's just I like to title the axes so we know what they are. All right. So you can click on the chart or go to Chart Elements and hit that plus sign. Okay, so when you get to chart elements, we've done this before. I want to click on axes titles, right? And yeah, and then let's label the axes. So this one is this is demand and this is price. All right. So you can see the corresponding demands and the corresponding prices. So just add the axes titles and change this title to demand.
Can you show me how you added the titles again?
Sure. Okay, so you got your chart, and you click on the chart, and you have the plus sign, you go to Chart Elements. Okay, so if you can get to Chart Elements, or just hit the plus sign, you should see the option for Axes Titles, and click that box. Okay, and that should do it. Did that work?
I'm on a Mac, so I don't have chart elements.
Oh,
But
so yeah, I think there's when you click on the chart up here, you should see something like Chart Design and Format, and it's up here somewhere, I think. And
okay, I found it.
add chart element. Do you see that?
Yeah, and then you said chart title.
Yeah, so once you go to Add Chart Elements, just click on Chart Titles, and if it looks like this,
Yeah.
you can choose, or not Chart Title, Axes Titles.
Oh, my bad.
Yeah, Axes Titles. So you can choose the primary horizontal and the primary vertical.
Okay, and which one do you click? Primary horizontal or primary vertical?
Well, I did it. Mine was a shortcut to doing both, but you want to do them both, so you can do one and the other.
Okay.
So you can do it. I don't know why it doesn't have the option for both, but yeah. So do the horizontal and the vertical. Just do them each separate.
Okay. Thanks.
Yep. All right. And then when you get those titles, all right. Yeah. So if you're using a Mac, I don't think you have this plus sign, this little shortcut for chart elements. You might, but everything we're doing with the plus sign or the chart elements is up here in the drop-down menu for Mac or different versions of Windows. And so there's also this add chart element, which gets you to the same place. It just takes a few more clicks. Okay, so either click on the plus sign for add axes titles, or go to the axes titles drop down and choose it like that. Yeah, so I've noticed that like doing the chart formatting is the biggest, uh, the most discrepancies between Mac and Windows, and so yeah, usually there's a little bit of disconnect there, but we can get to the same solution. So, all right, so just change this axis title manually. Just delete it and type in demand. Okay, and then just type in the other one, which is price. So the x-axis is price, and the y-axis is demand. So we're trying to see how price affects demand, right? That's what we're trying to do. Okay, so if we got that, yeah, so if we got that, we can, what I want to do is just make a copy of this chart and paste it a couple more times. And so rather than doing it all again, we can use it, we can use the same one to do all three types of curve fitting analyses. So if you click on the chart, and you can, the shortcut to copy is Control C. Okay, if you click on the chart and hold down the control button and then C, that'll copy it. And then when we paste it, that's Control V. Okay, so Control C is copy, Control V is paste. Those are the shortcuts for those. Okay. So click on the chart and then hit Control C to copy it. And then just click anywhere else on the spreadsheet that doesn't have anything. So click another cell to the right like this, and then hit Control V to paste. Okay, and then you can do it one more time to have three of them, and just go to another cell to the right that has nothing in it, and just hit Control V again to paste a second time. Okay, so we want there is to have that same chart three times. Okay, so did we get that? We got the chart with the titles, and we pasted it two times, so we got three of the same chart.
Yeah.
Okay, great. And so does Control C and Control V work on a Mac, or is it like Apple C? What's
It's
the
command.
Command C?
Yeah. Command C, Command V.
Okay, yeah. So those are, I think you guys know your shortcuts, but yeah. So Command C and Command V for Mac version. All right. So when I say Control, that means Command for Mac. Yeah. Okay. So step two. Okay. So we got a scatter plot. Actually, we have three scatter plots. And the first type we're going to do is look at a linear fit. So we're just going to look and see if there's a linear relationship between uh, price and demand. Okay, so we'll use Excel's trendline tools to find the best fitting straight line or best fitting linear curve. Okay, and we'll display the equation on chart, and we'll use that in a minute. But the general form, which we're using for linear, is y equals a plus bx, where y is the independent variable, which in this case is demand. A is the intercept, and B is the linear slope or the linear relationship between x and y, and x is going to be price. So we're looking at if there's a linear relationship between x and y, where x is price and y is demand. Okay. So back to the spreadsheet. Let's estimate a linear trend line. So we'll use these trend line options quite a bit because they're pretty useful at seeing if there's a relationship between two variables and what is it. Okay, so first, the first one we're going to do is linear. So let's just change the title from demand to linear. Okay. So that's the linear fit. All right, we'll get to the other ones in a little bit, but first, let's estimate the linear fit with the treadline tools. And so the best way to do it, if you have the chart elements, is click on the plus sign, or click on the chart, click on the plus sign, and then down here where you see treadline, you should see a little arrow. All right, and click on that arrow, and then go to more options. Okay, and I can do this a few times, I'm sure it'll take a few attempts. But if you're here, right, you got the linear selected, so you want that. That's the default. And if you scroll down, you should see an option or a box to check that says display equation on chart. Right there. Okay, so if you got this far, that's what you want, is the linear fit, and you want to display the equation on the chart. And if that worked, it should give you the line, see, and the equation. Now, if you're using a Mac, I think you have to click on the chart, and under chart elements up here, where it says add chart elements, you want to go to trend line and more trend line options. Actually, let me do it. I don't want to double it up on, so let me get back. All right, so if you got this, leave it. If you're using a Mac, or you have to do it this other way without the chart elements, let me do it that way too. Okay, so using the drop-down style, click on the chart, click on the drop-down for add chart element.
Is that under insert?
Oh, so when you click on the chart, it should just default to chart
Oh,
design.
chart design.
Yeah.
Okay.
And if it doesn't, just click on the chart design thing. And then under chart design, add chart element here. Go down the tread line. Then more trend line options. Okay, then hopefully it takes us to the same format trend line menu. And so you want the linear, and you want to click on display equation on chart, and that should get you to the same place that we did with the chart elements. Okay, so we got this linear trend line and we got the equation, right? Does anyone need me to do that again? Did everyone get the trend line? Because we're going to do this a bunch of times, so just let me know if you didn't get the trend line process. All right, so either of those ways will work. Okay, so looks like we got this. And so what I'd like to do is format it so there's just only a couple decimals, so it's a little easier to work with. And so if you got the little equation here, right click it, and you should see format trend line label.
How did you get that equation?
Oh, let's see. So when you're getting, did you get the trend line?
Yeah, I got the trend line. The linear or the what's it
Yeah. So
called?
when you were putting in the trend line, there was a box to check for display equation on chart. So
Oh,
you might want to do it again.
okay.
So here, I'll do it one more time. All right. So if you undo and get back to just the chart, all right. So on the chart, chart design, and then add chart element, and then trend line, and then more trend line options. Okay, so when you're here, you need to go down and choose display equation on a chart. All right, there should be a little box to check.
Oh, okay, I got you. I got
Okay,
you.
so does that work?
Yep.
Okay. All right, so if you got the trend line and if you got the equation, let's just click on the equation and right click it and choose, if you got it, format trend line label, and just change the category here to number. Okay, and that should work, that should do what we want. Okay, so you should have this little equation here that says y equals negative 0.35x plus 211.31. So this means that this is, so this little, if this relationship is a linear one, right, if these, when price goes down, when price goes up, demand goes down, which it should for a demand curve, you can see these are different points. And so this is saying that if there's a linear fit, this is the best linear line. And so see how the dots kind of fluctuate around the line. So it looks like a pretty good option, but we're going to compare some other options as well. So this is the linear fit, and this is the linear equation that describes that fit. So this is the linear relationship between price, x, and demand, y. So this would say that basically every time x changes by 1 unit, which is $1, the demand goes down by 0.35 units, which is golf club sets. Okay, so we got the little trend line and we got the equation, and we'll come back to that. All right, so if we got the linear fit, the next thing we're going to do is estimate a power fit for the other graph, and then for the last graph for an exponential fit. And then we're going to compare all the types. Okay, so keep that there. Make sure you're saving this. All right, so is the demand curve a linear fit? We don't know. We're gonna find out, but let's try a power fit as well. So it's possible that this relationship is nonlinear, which it looks like it might be if you look at the data. Okay, so it looks like the relationship is more curvy, not linear, right? As you get to more extreme values, that relationship either gets steeper or flatter. And so it's possible that one of these other types of fits models this relationship better. So the point is to take these data points and find the best fitting relationship that captures what happens to demand when price changes. Okay, so maybe it's linear fit, maybe it's a power fit. We'll try that for step 3. So for step 3, let's again use the power fitting, the trend line tools to estimate a power fit. And the power fit general equation is this. Okay, so again, y is demand, x is price, a is some constant, and then b is the exponent. So it's possible this type of relationship is the best one for how demand changes when price changes. So let's find out. Okay, back to the spreadsheet. All right, let's go ahead and call this second graph. Let's call this power fit. Okay, and we're going to do the same thing. We're going to add a trend line, but instead of doing a linear fit, we're going to add a power fit trend line. So you can click on the chart. All right, I'll do it both ways. Click on the chart, click on the plus sign for chart elements, and then go down, if you have this, to the trend line and see the arrow. and then choose more options. And once you get here, you want to choose power, right? See there? See how it's a more curvy nonlinear fit, which looks like it's a pretty good one. And you also want the equation for the power fit, so if you scroll down, you can click on display equation on chart, and if that worked, you should have the power fit little curve, see it? And then the power fit equation. All right, and I'll do it one more time with the other method. Okay, so click on the graph. Click on the graph and then chart design, and then add chart element, and then down to trend line, and then down to more trend line options, and then choose the power fit. Okay, and then display equation on chart. Okay, so both of those methods should get you to this. And then last thing we'll do here for this one is just let's format the number label again, just so it looks more readable. We can't work with this 6e plus 06 thing. So click on the little equation, and then right click it, and then format trendline label. And again, just change the category to number. Okay, so there we go. This is our power fit equation. If the demand curve is a power fit relationship, then this is the best power fit equation between price and demand. Okay. Okay, so if we got that, let's get the last one, which is the exponential fit. Okay, we'll again use the trendline tools, and this time we'll choose exponential, and the exponential fit is another nonlinear option, which looks the general form like this. Okay, again, where y is demand, x is price, and then these other things are parameters, and e is the mathematical number e, which is like 2.71, something like that, or 2.17. I don't know exactly. Yeah, 2.71 and so on. So you probably from basic math or whatever the algebra arithmetic you learn about, you use the number e, and this is what the number e is used for. It's a nice mathematical number, which just is 2.71 and a bunch of other decimals, but it helps estimate the linear or the exponential fit here. So e is just a constant of 2.71 that has some nice mathematical properties. All right, so let's estimate that exponential fit by the same way. All right, you know what we're doing. We're going over to that third graph. We're going to change the title to exponential fit. And if you know the process, we're going to do the same thing. The only difference is we're going to choose exponential fit instead of the other options. So click on the chart. Okay, plus sign for chart elements, then go down to trend line, hit the arrow, and then more options. All right, so again, you want to choose the exponential fit because that's what we're doing here. So choose the exponential option and click the box for display equation on chart. All right, and then I'll do it one more time the other way just to make sure that we got it. Okay, so if you're on a Mac or you're using the drop-down menus instead, click on this chart, then chart design, and add chart elements, then down to trend line, and then down to more trend line options. Okay, and then over here when you get this little format trend line display menu thing, choose exponential, and choose display equation on chart, and that should get you to this point here. All right, and then one last time, we're going to format this equation to look a little more readable with just a couple decimals. So you can click on that equation. You can right-click it. You can choose Format Trendline Label. And you can change the category to number. Actually, that might be a problem because we gave us just 0. So let me revisit this. So I want to add, all right, so if you click on the, right-click the equation again, and go back to Format Trendline Label, let's just add a few decimals because right now it has 0.00 and that's not going to work. So let's just change the decimals to 4. There we go. All right, so now we got negative 0.0049, which is, that'll work. Okay, so if you got that, your equation should be this here, which is 466 point a bunch of decimals, and e raised to negative 0.0049 times x. All right, so we got hopefully the linear fit with the trend line in the equation. We got the power fit with the trend line in the equation. Then we got the exponential fit with the trend line in the equation. All right, so everyone good so far? We got all these steps done?
Professor, what did you change to 4?
I'm sorry, what?
What did you change to 4?
Oh, okay, so I just changed the decimals on this display equation. So if you click on the equation and right-click it and go to Format Trendline Label, I just changed the decimal places to 4 instead of 2 because when you round up, it was like 0. So just change your decimals here to 4.
Okay, thank you.
Yeah. All right, did that work?
Yeah, it works.
Okay. Okay, next step. All right, step 5 is all we're going to do here is we're going to manually enter the parameters of the best fitting curve. So we're going to use them in some general equations. All right, so back to the spreadsheet. Okay, so we're going to type in manually the parameters from each of these types. All right, so see over here where it says parameters of best fitting curve. Intercept, we want to just type in the intercept that you got from your equation, which is 211.31. Just type that in. Okay, and then you can type in the slope of the linear curve, which is just from here. This is where I'm getting it, negative 0.35. Okay, type those in, and then let's type in the constant from the power relationship, which is this big number here. So it's 5,871,000. Here, I'll start to. All right, so 5,871,064.20. Okay, I'm just reading it from this equation over here, and then the exponent for the power is x is raised to negative 1.91. Okay, and then for the exponential, the constant is 466.5101. All right, and the exponent is right here. See, it's negative 0.0049. All right, so just type those values in right there that you got from your estimated equations. Okay, so you should see that you have three general formulas there for each of the types. And so in cells E19, E19, F19, and G19, you're going to type in these equations in order. So the first one goes in E19, the second one goes in F19, the third one goes in G19. All right, and we'll get the general equations for the linear and the power and the exponential. All right, so let's go ahead and type those big equations in. All right, so in cell E19, here we are right here under the predictions for linear right there. Type in this equation. Okay, equals $B, $19 plus $B, $20 times B4. Okay, and what all that's doing is it's taking, we're estimating a linear relationship based on the actual price data. All right, so here's the first price, and we're plugging it into this equation. Basically, we're saying, here we go, the intercept plus the slope times the exponent. So we're just specifying this general equation with the parameters we got for the real data, and we're trying to see how the prediction is based on, so when price is 450, what is that value of demand on this line? When price is 300, what is that value of demand on this line, and so on, and we're going to compare the linear prediction to the actual demand data, all right? So the first one should be 553.81, and the actual demand was 45, well, these are in hundreds, but 53.81 compared to 45, so it was a little bit off for the first one. All right, and then in F19 right here under power, type in the equation you see there for step 6. Okay, so equals $B, $22 times B4. Raised little caret sign, so raised to $B, $23. Okay, so again, all we're doing here is we're taking the actual pricing data for X and plugging it into the equation for the power fit and seeing what our estimated demand is based on the power fit. So we're taking the actual X data, putting it into the power equation, and seeing what we get for demand and comparing it. So we get 50.24. And again, the actual demand for month 1 was 45. Okay, and then the last equation for step 6 goes here in G19. So equals $B, $25 times, and make sure you see that EXP, so get the EXP, the exponential function, which is going to take the little number e and raise it to this stuff in parentheses. So it's basically $B, $25 times number e raised to, and then in the parentheses, $B, $26 times B4. Enter. And so again, what we did here is we plugged the actual pricing data into the exponential equation, right? And we're seeing what we get for demand and comparing it to the actual. So when we take 450 and plug it into this equation, right? 450 goes in there for X, we get Y, or demand equals 51.43. So this was the prediction for the linear for demand for month 1. This was the prediction for the power for month 1. And this was the prediction for the exponential for month 1. And the actual demand was this. All right, so month 1 wasn't a great prediction for any of them. That might have been an outlier, but we'll hope that some of the other months are better predictors. All right, so if we got this equation and this equation and this equation, what we can do one second here. All right, sorry about that. Let's okay, so if we got those equations, what we can do is we can apply them down for all the other months, because we set up the equations as such that they're just gonna apply the next piece of data. So you can select this area with the three equations, select E19, F19, and G19 all together, and then we're gonna grab the right corner and drag it down to capture the piece of data for the next 12 months. And actually, let's do this. Just for a reference, let's put the actual month here so we know what we're doing. So in D19, just type in a 1. In D20, just type in a 2. Okay, and you can select them both and just use Excel's shortcut tools. All right, this is 1, this is 2, and then select them both. D19 and D20, grab the bottom right corner and count up to 12. All right, so there we go. This corresponds to the months, 1, 2, 3, all the way through 12. So in this area, I suppose we could have just copied and pasted this as well, but we didn't. All right, so this is month 1 and so on. Okay, and then what you're going to do is select the three equations again, E19 to G19, and then grab the bottom right corner and drag it all the way down to apply all the equations to all the months, and we'll get estimates for each type of prediction for each of the real prices. All right, so we're plugging the price in for all the months and getting the estimated demand for each of the types of equations. So here we go. Grab the bottom right corner. And you can drag it down like that, and you should get a linear prediction for demand for each month, a power prediction for demand for each month, and an exponential prediction for demand for each month. And again, all we're doing is plugging in these prices into the general equations for each respective type. Okay. Okay, did we get all this here? The predictions?
Wait, I got different numbers for the exponential column.
Okay, it's likely because something happened in the equation. So let's check your equation. Go to G19, or you might have typed in different. All right, first do these numbers look exactly the same?
Yeah.
Okay. Then let's look at this equation. Is it equals $B $25 times exp function? And then in the parentheses, $B $26 times B4?
Yeah.
And this number is different?
Yes.
What is this? What does G19 say?
374.2.
Definitely different. I mean, if the equation, so like, let's check that all right, so see how this is taking in the 466 times exp, and then this is taking in the exponent and just multiplying it by 450. So when you have when you click on the equation for G19, do you see that it's highlighting these things? 450, 466, and negative 0.0049?
Yeah.
Well, I guess I'll have to look at it because it seems like you're doing it right. But if you want to post it to here.
Sorry. Actually, I figured it out.
Oh, okay. What was the problem?
I just had an extra 0 in
Oh,
the
okay, yeah, that'll probably do
exponent.
it. Yeah, so
Yeah.
an extra zero in the exponent makes a big difference. Okay.
Yeah. Thank you.
All right, and then just once you fixed it, just drag it down and it should give you these, yeah?
Yeah.
Okay. All right. Okay, so we have the actual data for 12 months of price and demand. We now have three different predictions, right? Is this the best prediction? Is this the best prediction, or is this the best prediction? We had to find out by doing some error checking, seeing which line captured the data the best. It looks to me like it's either I can't tell just by looking at it, but you can see that it looks like either the power fit or the exponential fit are pretty good predictors, right? They both kind of, the lines kind of go through the data points. So it looks just by the eye test, one of these two, but I can't tell exactly without doing the analysis. Oops. Okay, so step 7 is to estimate the absolute percentage errors, and then the mean absolute percentage error. So the percentage error is just how far off the prediction was from the actual data in percent terms, right? Pretty simple. And we're going to use this simple formula, put it in H19, and copy it to the rest of the ranges. And then we'll get the average to get the mean absolute percentage error, which is just the average of all the errors. Okay? So the APE, which we're estimating here, is just the observed demand minus the prediction divided by the observed. Okay. All right, back to the model. Okay, so in H19, put in that equation you see there in step 7 equals, we're in cell H19, the formula is equals. Okay, equals ABS, which is the absolute value. Just take away the negative sign if there is one. All right, so equals ABS function in the parentheses, $C4 minus E19 divided by $C4. So what this is going to do, all right, so see how I gave us percent? So all we're doing is we're saying this was the linear prediction, this was the actual demand. How far off was this from this in percent terms? And so this was about 20% off of the actual. So it's just, the equation is just this minus this divided by this, and how far off this was from that.
I think I typed in the formula wrong. Could you reread it?
Yeah. So here we go. It's to make sure it's equals ABS function, and then in the parentheses $C4 minus E19, close the parentheses, then divided by $C4. So it's just absolute value of actual demand minus predicted demand divided by actual demand.
And you got 19.58%?
Yes.
Okay, I'm good. Thanks, man.
Okay. Yep. Okay, and if we make sure that we got those dollar signs in the right spot, because we're going to apply it to this whole other area. All right, so if you got this equation that gave us 19.58, let's go ahead and click on H19, grab the bottom right corner and drag it over to the power of the exponential like this. Okay, and then you can leave those three selected. What do we got? H19, I19, and J19. And grab the bottom right corner and drag this one down all the way to month 12. Like that. And that should give us the absolute percentage error for each of the types for each of the months. All right, and then right here where it says MAPE, all that means is the mean or the average of the APE. So let's just take the average of this, the average of this, and the average of this, and see which one is lower on average. So in H32 equals average of H19 to H30. Enter. All right, and then you can take the average of these two by just dragging the formula over. So click on this function, the average function in H32. Grab the bottom right corner and drag it over like that and like that. Okay, and so this should be the MAPE for the linear. This should be the MAPE for the power. And this should be the MAPE for the exponential. Okay. All right, so we get all that for step 7?
No, I didn't see the I'm sorry, I was finishing up the last little type of the average that you put for 10.5.
Oh, so you
Yeah,
got this,
yeah.
you got this part? How far have you, which part do you need to? Okay, I'm not, so what part do you need?
I'm sorry, can you hear me? I'm sorry.
No,
I said I think I got it now. I'm so sorry.
Oh, it's okay. All right, so you got these numbers here?
Yes.
Okay, great. All right, so we're gonna do a few other error checks, but the point is of these errors is to see which one captures the data the best. All right, so if this one was on average about 11% off, this was 6.18% off, and this was 6.51% off. All right, so which one, just comparing the three, which one is the better option so far? So you can see that this one had the lower error on average. So just based on looking at the APEs and the MAPEs, we would choose the power fit. But so let's go ahead and highlight the lower percent for that one for now. Okay, so the power fit had the lowest MAP, right? So that means that, yeah, it was, the data was closer to the actual prediction. Okay, then next step is step 8. All right, so then let's estimate a squared error, which is just the difference between the actual and predicted, then square it. Okay, and then we'll get another error measure is the root mean squared error, which is the square root of the mean of the squared error. All right, so just big acronym. And then we'll calculate the absolute error, which is just the difference, like actual minus predicted. And we'll get the average of that. Okay, so 2 more error types for step 8. All right, so here we go. In K19, type in the formula you see there in step 8, which is equals. Okay, so equals E19, equals, make sure you get this parenthesis, equals parenthesis. In the parentheses, E19 minus $C4, close the parenthesis, and then raise it to 2. So put the caret sign, so it's all, the squared error is exactly what it says. It's the difference between the actual and prediction, and then square it. So the difference squared, raised to the 2. Okay. All right, and then you can probably see that we're going to apply the same formula to the rest of the range. So if you got this here, 77.62, you can click on K19, grab the bottom right corner and drag it over here to the power in the exponential. All right, and with those three selected, if you got these numbers, 77.62, 27.50, and 41.38. Okay, so you got K19 through M19 selected. Grab the bottom right corner and drag it down all the way to month 12. All right, so you should get the squared error for each month for each type. And then down here, we're going to get the root mean squared error, which is the square root of the mean of the squared error. All right, so in K32 equals this function, SQRT, okay, which is the square root function, and then the average inside the parenthesis. All right, and then of this whole range. So square root of the average. And then close the parenthesis. And one more parenthesis. So it's a little double function here. So we got equals SQRT, and then in the parentheses, average. And then in these parentheses, K19 to K30, and then double parentheses. Okay, so equals square root of the average of the range. All right, and we get 7.95. And then you can get the RMSE for the other two types by just clicking on,
You got 7.95.
yes, yeah, 7.95.
I got 6.65.
Well, it's either, so are these numbers looking the same under the linear, like 77.62?
Yep, 10.96, 69.06.
Okay,
Yeah.
so if those are all the same, then we gotta, so let's check this equation. So this should be equals SQRT, which is square root, and
Yep.
then parentheses, average, parentheses, K19 to K30.
Yep. K19 to K30. My bad.
Yeah.
I put K20. All right, 7.95. Beautiful.
There you go.
Thanks.
Okay. Yep. All right, and then if you got that, like we do now, you can drag the RMSE formula to get the power in the exponential. So click on K32 and grab the bottom right corner and drag it to the power in the exponential to get the RMSEs for those, like this. Okay, and we should get 7.95, 4.95, and 5.55. So that would tell us that looking at the RMSE, again, the power fit has the lowest error of this type. So we can make a note that we did 2 checks and the power fit had the lowest error of both types. So I'm going to highlight this. Okay. All right. Did we get all the squared error stuff here? Okay, so the last error check type is the absolute error and then the MAE, which is the mean absolute error. So the other bold formula you see in step 8 goes here in N19 equals ABS, which is absolute value, equals ABS in the parentheses, E19 minus $C4, which is just the absolute value of actual minus prediction. So how far off was it? Just in take away the negative sign. Okay, so 53 minus 45 is 8.81. Okay, and then again, we're going to apply this same formula to all the other range. So you can click on N19, grab the bottom right corner and drag it over to power and exponential like that. And if you got these values with N19 to P19 selected, you can again grab the bottom right corner and drag it down for all the months, and you get the absolute error for each month for each type. All right, and then the mean error is just the mean of the error. So let's just take averages starting in N32 equals average. Equals average of N19 to N30. All right, the average of all 12 linear absolute errors, enter. Okay, and then to get the average of these other two, you can just grab the bottom right corner of N32 and drag it over to the power and the exponential. And these are the mean absolute errors for the three types. And again, if we get 6.65, 4.39, and the lowest is 4.23, of all three error checks, the power fits seem to be the best fit. Okay, did we get that stuff for the absolute error and the MAE?
Yeah.
Yes.
All right. So what we've learned so far for the first tab is that we compared three types to estimate a demand curve, and it looks like this was the best fit, and it looks like that's just by the eye test, that probably looks like the best one. All right, so this is the equation and the fit we're going to use for the demand curve. Okay. All right, so we finished the first tab. Let me see what time it is. Oh, it's Um, all right, so we still have a whole, I don't think we're going to finish the profit model because we got a whole bunch. All right, so this, what time is this class goes to 9:15, right? So we can either.
Yeah, 9:15.
Yeah, it's about 9 o'clock. So why don't we just do this? We need to do, we have a whole, we've done half the exercise. All right, we've done the estimation tab, and we have to do the whole other profit model with the with the appropriate power fitting curve, and that's going to take a while. And so I think the best option is probably just to save this and finish up the profit model on Wednesday. And then I know that we have one more thing to do on Wednesday, but we should have time to do that. So if everyone can save this and have it ready to go on because this is basically 2 exercises, and I knew that we wouldn't finish it. So if you can save this whole spreadsheet and have it ready to go on Monday, then we can start and do the second portion of the exercise on Wednesday, which is to use the profit model. And so what we want to do now is, because we got the estimation tab done, we're going to use this equation with the power fitting curve and parameter to do a profit max model and look at what price we should charge and change some things and do some little sensitivity analysis. So this is the profit model part is basically a whole nother exercise. Okay, so does that sound good? Should we end a few minutes early? And if everyone can save this and have it ready to go on Wednesday, we'll finish it up then. So can everyone save this and pull it up ready to go on Wednesday?
Yes, sir.
Yeah, sounds good.
Okay. All right. So save it now. And basically, like, when we start on Wednesday, I'll pull this up and we'll have this part ready to go, and we'll start here. Okay. And then because I know this will take at least half an hour or so, and then we got another thing to do too. Okay. So let's stop here. Let's stop a little early because there's no point starting this and then just then ending it. Save this. You don't have to turn it in yet because we're not done with it, but do have it ready to go on Wednesday. And so I think we'll stop here and finish the second half on Wednesday morning. Okay, sound good? So have a good rest of your week, and stay safe. And I'll see you Wednesday morning.
Thank you, Professor. You too.
Thank you, sir.
Thank you.
Thank you. Thank you, Professor.
Thank you. Cole, you still there? Everything good with you?